welcome back to my YouTube channel. Today I will explain Fleury's algorithm, which is a graph traversal algorithm used to find Euler paths and Euler circuits. This algorithm is simple, easy to understand, and has important applications in network routing, circuit design, and route planning. Let's begin by understanding the basic concepts behind the Euler paths and Euler circuits. Before we begin, let's see what we're going to learn today. First, we will understand Euler paths and Euler circuits are. Then we will learn the conditions needed for learn to exist. After that, we will study Fleury's algorithm step by step and solve some examples. Finally, we will see how this algorithm is used in real-world applications. Before learning Fleury's algorithm, we need to know what a graph is. A graph has two parts: vertices, which are the points or nodes; edge, which are the lines connecting the nodes. For example, A, B, C, D are the vertices and the lines between them are edge. Graph traversal simply means moving through the graph by following its degrees. Why is this important? Because many real-world systems can be represented as graphs. For example, road connecting circuits, computer networks, circuit design, and delivery route planning. Fleury's algorithm is one method used to traverse such graphs. Now, let's look at where this idea came from. In 1736, a mathematician named Leonhard Euler was given a challenge called the seven bridge of Königsberg problem. People want to know whether it was possible to cross every edge exactly one time without repeating every bridge. Euler studies this problem and discovered the basic rule behind the Euler paths and Euler circuit. Because of his work is he known as the father of graph theory. This is one of the most important concepts. A Euler path is a path that uses every edge exactly once. Notice that we are talking about edges, not vertices. In this example, we start at A, move to B, then move to C. The edge between A and B is used once. The edge between B and C is also used once. No edge is repeated. Therefore, this is an Euler path. The path does not need to return the starting point. An Euler circuit is very similar to an Euler path. Again, every edge must be used exactly once. But there is one extra condition. We must finish at the same vertex where we started. In this graph, we start A, move to B, then C, then D, and finally return to A. Since every edge is used to once and we return to the starting point, this is an Euler circuit. A, B, C, D, and A. How do we know whether an Euler path exists? We simply check the degree of each vertex. Degree means the number of edges connected to a vertex. Let's count. Vertex A has one edge, so degree is 1. Vertex B have 2 degrees, so degree is 2. Vertex C have 1 degree, so degree is 1. Notice that A and C have odd degrees. Exactly two vertices have odd degrees. Whenever a connected graph has exactly degree vertices, an Euler path exists. Now, let's see the condition for an Euler circuit. Again, we check the degree of each vertex. Here, A has 2 degrees, 1, 2. B has also 2 degrees, 1 and 2. C has 2 degrees, 1, 2. D has 2 degrees, 1, 2. All vertices have even degrees. Whenever all vertices have even degrees, an Euler circuit exists. Now, let's finally discuss Fleury's algorithm. The purpose of this algorithm is to find an Euler path and Euler circuit. The main rule is very simple. Never choose a bridge unless you have no other choices. It means never choose a bridge unless there is no alternative. Why? Because if we remove a bridge too early, the graph may become disconnected and we want to be able to visit all edges. So the algorithm always tries to keep the graph connected until the end. Important terminologies in Fleury's algorithm. First, vertex. A vertex is simply a point in a graph. Example are A, B, C are the vertexes in this graph. Edge. An edge is a line connecting two vertices. Degree. The degree of vertex is the number of edges connected to it. Bridge. This is very important. A bridge is an edge that, if removed, breaks the graph into separate parts. In this example, edge BC is a bridge. If we remove it, vertex C becomes disconnected. That's why Fleury's algorithm avoids bridge whenever possible. Let's learn the algorithm step by step. Step 1. Check whether an Euler path or Euler circuit exists. Step 2. Choose the starting point. If it is an Euler path, start from an odd degree vertex. If it is an Euler circuit, start from any vertex. Step 3. Choose an edge that is not a bridge. Step 4. Travel through the edge and remove it. Step 5. Repeat the same process until all edges are visited. That's all. Those are the 5 steps of Fleury's algorithm. This graph looks complex, but let's solve it step by step. First, check the degrees. A. A have 2 degrees, 1 and 2. B have 4 degrees, 1, 2, 3, 4. C. C also have 4 degrees, 1, 2, 3, 4. E. E also have 4 degrees, 1, 2, one, 2, 3, 4. D also have 4 degrees, 1, 2, 3, 4. F have 2 degrees, 1, 2. Notice something, every edge is even. So an Euler circuit exists. One possible Euler circuit is A, B, D, F, E, D, C, E, B, C, A. Let's check. Did we use every edge? Yes. Did we repeat any edge? No. Did we finish where we started? Yes, we start at A and ended also A. Therefore, it is an Euler circuit. Now, let's look at an Euler path example. First, count the degrees. Vertex A have 1 degrees. Vertex A have one edge, so degree is 1. Vertex B has 2 degrees, so degree is 2, 1 and 2. So vertex C has one edge, so degree is 1. Notice that A and C have odd degrees. Exactly two vertices have odd degrees. Whenever a connected graph has exactly two odd degree vertices, an Euler path exists. Let's look at the advantages and limitations of Fleury's algorithm. Advantages are easy to understand, simple implementation, good for teaching graph traversal. The limitations are requires bridge checking repeatedly, less efficient for large graphs, and slow the Hypothesis algorithm. Fleury's algorithm is not only a classroom topic, it can be applied in many real world situations. For example, route planning for vehicles, designing communication networks, planning cable and pipeline systems, electric circuit design, delivery and logistics optimization. All these problems involve finding efficient paths through the connected networks. Let's quickly review that we learned. An Euler path use every edge exactly once. An Euler circuit use edge exactly once and return the starting point. Euler path need two odd vertices. Euler circuit needs all vertices have even degrees. Fleury's algorithm help us find this path by avoiding bridges whenever possible. And finally, this algorithm has many practical applications in routing and network system. That brings us to the end of this video. Thank you for watching my video, and if you found this video helpful, please like, share and subscribe to Code with Kavindiya. Don't forget to press the notification bell from your programming and algorithm tutorials. See you in the next video. Thank you and have a great day. Bye bye.